Hello, 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 hello. Hello and good afternoon to everyone who will be watching the video and who will not be watching the video, to them as well. So, just like how we discussed yesterday, few questions on matrices and determinants. Today also we are going to cover few questions which have been previously asked in JEE mains, sorry, in JEE advanced. And for today, like our yesterday, there are various type of questions that comes in JEE advanced. First is single correct answer type. Second is more than one answer correct type. Third is assertion and reasoning. And fourth one is integer type or numerical answer type. So yesterday we did few questions based on these two types. Today also we will be doing few of the questions of these types, but our major focus will be on integer type and numerical answer type, because to get to the answer of integer type, we all know that the integers are limited for that answers, and generally these questions are easy if you catch the concept. So, with our main focus being the integer type of questions, let us begin with our main focus being the integer type of question. Let us begin our session and proceed with solving the question, guys. Okay. I hope I am audible and my screen is visible to all of you. Welcome to whoever is joining the class. Hi, hello. Hi, Nihal. Hi, Nihal. Hi, Usman.
Hi, sir.
Yes. So yesterday we had one session like this in which we discussed few questions. You can watch the session on our YouTube channel. And today we are going to carry forward and move ahead with another type of questions. Mainly integer type of questions is what I was discussing. And let's see what these questions are. So first of all, Nihal, Usman, and whoever else might be coming. Yesterday there was less audience. So congratulations to you guys for clearing the exam and going, like, you have been selected to give advanced exam. So that is a very great feat to achieve. So congratulations to all of you. Let us begin our session. Okay. So here in this question, I hope this screen is visible to you guys. So here you can see the question. It is saying that determinant of this particular thing is given to us as minus 648 alpha, and we have been asked the values of alpha. Which of the following values of alpha satisfy the equation? Okay. So no need to get panicked over the fact that this looks pretty dramatic and difficult. All these terms in the determinant are pretty big, but if you know the multiplication of two determinants, okay, so here I am just telling you how to multiply two determinants. Consider a determinant a b c d e f g h I, and this determinant is multiplied by another determinant p q r s t u v w x. So if you guys will remember, if you guys can if you guys can remember, then the multiplication of these two matrix, the outcome looks something like this: AP plus BQ plus CR, then AS plus AT plus AU, then AV plus AW plus AX, and DP plus EQ plus FR, DS plus ET plus FU, dV plus dW plus dx, and the last being Gp plus HQ plus IR, Gs plus HT plus IU, Gv plus Gw plus Gx. So this looks very big, but it is easier to understand. So here you can see this AP plus BQ plus CR is elements of first row of this matrix into elements of first row of the another matrix. Then this is element of first row into element of second row. This is element of first row into element of third row. So this is how you do the multiplication of two matrices. So in the given question, the matrix is given to us as 1 plus alpha square. Okay. 1 plus 2 alpha square and 1 plus 3 alpha square. Then 2 plus alpha square. Then 2 plus 2 alpha square. 2 plus 3 alpha square. 3 plus alpha square. 3 plus 2 alpha square. 3 plus 3 alpha square. And this is told to us that it is equal to minus 648 alpha. So what we will do here is, I am going to first expand these terms, all these terms, and I write it down separately. So this will become 1 plus alpha square plus 2 alpha. This will become 1 plus 4 alpha plus 4 alpha square. This will become 1 plus 6 alpha plus 9 alpha square. Then another will be 4 plus 4 alpha plus alpha square. This will be 4 plus 8 alpha plus 4 alpha square. 4 plus 12 alpha plus 9 alpha square. Similarly, here it will be 9 plus 6 alpha plus alpha square. 9 plus 12 alpha plus 4 alpha square. 9 plus 18 alpha plus 9 alpha square. This matrix, you can see that can I write this matrix as the multiplication of two matrix, and what those two matrix will be: 1 alpha square, 4 2 alpha, 4 2 alpha, alpha alpha square, then 9, 3 alpha, alpha square into 1, 1, 1, this 1 to 1, 1, 4, 4, 1, 6, 9. So you can see, you can compare here first row of this matrix into first row of this. It will be 1 plus alpha square, which is our element. Then this matrix is given to us as minus 648 alpha. Okay, so this is given to us as minus 648 alpha. So now what I'll do here is I'll take alpha common from this row, from this column, and alpha square common from this column. This column I'll take alpha square common, and from this column I'll take alpha common. So I'll write it in the next slide. What I'll get is I'll get alpha into alpha square I have taken common, and then 149 1 1 2 3 1 1 1 into that other matrix remains unchanged. It will be 1 2 1 1 4 4 1 6 9. This is given to us as minus 648 alpha. Now here you will get alpha cube. Now determinant of these matrices. So this is 1, 2. The determinant of first matrix is what? This will become 2 plus 9 plus. I'm writing the determinant of first matrix. 2 plus 9 plus 12 minus 18 minus 3 minus 4 into, this will become 36 plus 6 plus 8 minus 4 minus 24 minus 18 equals to minus 648 alpha. What is this? 21, 23. This is 21 and 4, 25. So minus 25. This will become alpha cube minus 2 into 42, 850. Here it is 46. So 4 equals to minus 648 alpha. Now this becomes minus 8 alpha cube equals to minus 648 alpha. Minus 648 alpha. So minus minus gets cancelled. Here you will get alpha value as 8 ones are. This is 8 ones are. This is 8 80 ones are. So alpha cube comes out to be 81 alpha. So I'll take alpha and this will become alpha square minus 81 equals to 0. So the values of alpha which satisfy the equation can be alpha will be 0, alpha will be, alpha square is 81, these two. So from the second part we get alpha as plus minus 9. So these are the values that will satisfy the equation. So the correct answer to our question was, as you can see, this answer and this answer. So these two are correct answer to the question. I hope this question was understood by you guys. You can take your time to understand. I have just applied this property and simplified it, since it would have taken a long time to evaluate all these things. I have applied the property and written it down in this fashion. So this alpha square comes out to be from all the part. You can take 9 alpha square, 9 alpha square, 9 alpha square will be the third part. Okay, moving on further with the next question. Now in this question, as you can see, the question is telling us, let x and y be two arbitrary 3 into 3 non-zero skew symmetric matrices, and z be an arbitrary 3 into 3 non-zero symmetric matrix. Then which of the following is R skew symmetric? So to solve this question, the property that I am going to use is that the first property that I will be applying here in this question is that A plus B whole transpose is equals to A transpose B transpose. And the next property that I will be using is AB transpose is equals to B transpose into A transpose. So these two properties are required to solve this question. I hope you guys remember these properties. So now to solve the question, let us say like X and Y are two arbitrary 3 into 3 non-zero skew symmetric matrices. Okay. So X transpose will be equals to minus X, right? Since they are skew symmetric. And Y transpose will again be equal to minus Y because X and Y are skew symmetric, and Z transpose will be equal to Z because it is a symmetric matrix. Okay. So transpose of a symmetric matrix is equal to the matrix itself. And in skew symmetric, it is with the negative sign. It comes with the negative sign. So this is an important point to remember. This might help solve in different other questions as well. Now Y3. So within which of the following matrices is R skew symmetric? This is asking us. So we will check for all the options. So I am writing Y3 Z power 4 minus Z power 4 Y3. I am trying to find the transpose. Okay. To find whether it is a skew symmetric matrix or not, I need to find the transpose. And for for the transpose, if it comes out to be the negative of the matrix, if it comes out to be negative of this thing, then I can say it is a transpose, right? So the transpose of this will be y3 z power 4 transpose minus z power 4 y cube transpose. So I have just applied the first property in this particular scenario. Okay. So after applying this property, can I write this as Z transpose power 4 and Y transpose cube minus Y transpose cube into Z transpose power 4. Correct or not? I can write this thing, right? Here I have applied the second property which is written over here. Okay. So we all know that what is Z transpose? Z transpose is Z itself. So this will become Z power 4 itself, and Y transpose is minus Y. So we know that Z transpose is Z and Y transpose is minus Y. So can I write this thing as minus Y cube Z power 4? Okay. Here Y transpose is minus Y and Z transpose is Z. So this will change the sign. This will become plus and this will become Y cube Z power. This will become Z power 4 Y cube. So this is equivalent to Z power 4 Y cube minus Z power 4 Y cube plus y cube z power 4. Okay. So as you can see that this has not changed its sign. So this is a symmetric matrix. Hence, but we are supposed to find whether the others are skew symmetric or not. So for x power 44 plus y power 44, you write minus x power 44 plus y minus y power 44. So now I am checking. Now I am checking option. Now I am checking option D. So for option D, can I write what will be x power 44 plus y power 44 transpose? This will be x transpose power 44 plus y transpose power 44. X transpose is minus x power 44 plus y transpose is minus y power 44. So this will become x power 44 plus y power 44. Since this has not changed the sign after transposing, then we can say this is also symmetric matrix. Okay. So now we are left with third option. So third, as you can see, third, the powers are odd. So the x and y will become minus x and minus y and they will change sign. Hence, this will be skew symmetric. This will be skew symmetric. And for the for the for this option, you can see here the power of y was odd. So that is why this came out to be symmetric. So if the power of x was odd here, since x and y follow the same rule in this question, then it would have been symmetric. But since the power of x is even here, it will change to be skew symmetric. So to solve this question, you need not also find all the options. Only first option would only first option would tell you which one is the correct answer. So correct answer in this question is B and C because these two can be skew symmetric matrix. Okay. So this question was relatively easier, and even though like if you don't know much about matrices, if you know these two properties, you could have solved the question very easily. Okay. I hope it was understandable. Let us move ahead with the next question. Okay. Now here in this question, let us first try to understand what this question is trying to talk. This question is telling us that let P be a matrix of order, let P be a matrix of order 3 into 3. Let P be a matrix of order 3 into 3 such that all the entries in P are from the set -1, 0 and 1. So any element that you are supposed to put in P in the matrix P can take only these three values. Then the maximum possible value of the determinant of P is how much? Okay. So first of all, we should try to understand. Let's say the matrix is A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. So the determinant of this matrix will be what? We know how to find the determinant, right? So it will be A1, B2, C3 plus A2B3C1 plus A3B1C2. And for the minus sign, it will be A3B2C1 plus A1C2B3 plus A2B1C3. So this is what the determinant of this matrix will look like. Now I am saying, let's say this is our X and this is our Y. Okay. So the maximum value from this thing, like all this, you can say that this can be maximum when every particular value is 1. So this can become maximum as X will be maximum at 3, and Y will be minimum at -3, right? When all the terms are -1, -1, -1, then it can reach a value -3. So like the sum can be 6. So the delta maximum, delta max, determinant max can be 6, but it is not possible, right? But it is not possible, as when X is equals, like if you take delta max is possible 6 when X is 3 and Y is -3. So when you take X as 3, it means you have assigned the values of A1, B2, C3 as like A1 as 1, 1, 1. All the elements you have put as 1. And when Y is -3, it means you have put as -1, -1. So both cannot happen at the same time, right? So that is why this is contradictory. This is contradictory. Hence, delta max equals to 6 is not possible. Now the other part, like now the other is delta max can be 5 if you say, but for delta max to be 5, like you have to put 1, 1, you have to get 3 times 1, and here you have to get 2 somehow. Okay. So like you have to put 1, 1, 1 for all the elements here, and you have to put 1, 1, 1 here for all the elements, and then you have to put -1, -1 for these two part, and then this should be 0, which will again become contradictory, right? Because in the X part you have used all ones. Here you cannot use -1 or 0 to get to 5. So 5 is also not possible. Now the other possibility is delta max, delta X equals to 4, right? So for delta X to become 4, now you can put the values wherein you get 2 over here and you get -2 over here. So for this to happen, you have to put, like you can use the determinant. If you see the determinant 1, 1, 1 minus 1, 1, 1, 1 minus 1, 1. So in this you can see that the value of the determinant comes out to be 4. So all the entries are from this given set itself. So that is why 4 can be the possible outcome. So the maximum possible value of the determinant of P can be 4. So like let us just go through this question once again. So I have assumed this 3 into 3 matrix, 3 into 3 matrix to be like this. So the determinant value will look something like this. And I have said let this say let this is be X, this is be Y. Then X is less than equals to 3 is the greatest possible value is 3 for X. And for Y, minimum possible value is -3 when all the inputs are -1. So for for X to be 3, all the inputs are supposed to be 1. And for Y equals to -3, all the inputs are supposed to be -1, which both cannot happen like together, right? Which is contradictory itself. So that is why we check the next possible answer. Since all these are 1, 0, -1, it will take integral values only. So we are checking for the just next lowest value, which is 5. So for 5 to be the answer, these all should have to be 3 and this will have to be 2. So for this to be 3, all the input should be 1 1 1 itself. And for this to be 2, all the input should be like only for one part the input should be 0 also. For one part the input should be 0, which is again contradictory. And hence we move on to our other lower number, which is 4, and we can see that this determinant gives us the value 4. That is why 4 is possible when the determinant we take looks like this. Hence the answer is 4 in this question. Okay, so let us move further with another question. Okay, now guys, this is a question asked in JEE Advanced. But if you remember some basic properties about when the system has unique solution, when the system has infinitely many solution, when the system has no solution, if you remember such things, then you won't face any difficulty at all in answering the question that is given to us. So let us first try to understand the question. Let A, lambda, mu, all these be element of R. Consider the system of linear equations. Consider the system of linear equations ax plus 2y, ax plus ax plus 2y is lambda and 3x minus 2y is mu. Which of the following statements is R correct? Okay, so here the answer can be more than one. Okay, so for ax plus 2y lambda and 3x minus 2y equals to mu. For a equals to minus 3, for a equals to minus 3, this will become what? Minus 3x plus 2y. For a equals to minus 3, this will become minus 3x plus 2y equals to lambda, which will become 3x minus 2y equals to lambda. So, in this case, you can see when a is minus 3, so 3x minus 2y plus equals to mu and 3x minus 2y equals to lambda can be either coincident or parallel lines. Can be either coincident or parallel lines. So you can have either zero solution or you can have infinitely many solution. Yes. So this will be parallel. Now you can see that 3 you have gotten here as 3x minus 2y equals to minus lambda, and here you have been given 3x minus 2y equals to mu. So these lines will be parallel. Sorry. These lines will be coincident if mu equals to minus lambda. These lines will be coincident if mu equals to minus lambda, which means mu plus lambda. When mu plus lambda is 0, they are coincident. So when will they be parallel? The only thing left now is parallelism. So this will be parallel when mu plus lambda is not equal to 0. Okay. So this will be possible when mu plus lambda is not equal to 0. And when a is not equal to minus 3, when a is not equal to minus 3, you can see that this ax plus 2y will be some other line with other slope, and hence these two lines will become intersecting lines and they will have one unique solution. So if a is equals to minus 3, then the system has a unique solution for all values. This is correct answer. When lambda plus mu is 0, the system has infinitely many solutions for a equals to minus 3. This is also correct, right? We have seen that when mu plus lambda is 0, the lines are coincident. Coincident means infinitely many solutions. This is what it's supposed to be. when the lines are coincident, right? One line lying on the another line. So all for all the values of x or y, this will be same. So infinitely many solutions. So when lambda plus mu is not equal to 0, then the system has no solution for a equals to -3. Correct? When lambda plus mu is not equal to 0, the lines are parallel, right? Parallel lines, the lines are parallel, and as we all know that parallel lines do not meet anywhere, hence no solution. The lines are parallel, which means no solution. No solution exists. They won't meet anywhere. So this answer is also correct. Now, first option is if a is -3, then the system has many solutions, infinitely many solutions for all values of lambda and mu. We just found out that to have infinitely many solutions or for the lines to be coincident, there is one condition, right? Lambda plus mu should be 0. That is why it cannot be possible for all values of lambda and mu, and hence this is excluded from our answer. So for this question, the answer was option B, option C, and option D. So here guys, everything like you could have just checked option by option and you could have come to a conclusion which are the answer. So this was like very scoring. This was very scoring question. You required very basic knowledge of like the number of solutions for system of equations. Very basic knowledge was required. So the main thing is if you understand the topic by concept, then you will find the advanced questions very easy and you will be able to solve questions that look difficult or unique to you in terms of appearance will also be easier if you have understood the concept really well. Okay. So I hope this question was understood. I will move ahead and try to solve another question for you guys. Stay tuned. Now, here. Now, what does this question tell us? What is this question asking from us? Here in this question, a determinant has been given and you have been told that the value of this determinant is equal to 10. Then the number of distinct values of x for which this is possible, right? So this is our question. Now what I am going to do here is, first of all, what I'll do here is I will write it like this. Okay, so we know the properties of determinants, right? We know that a b c plus lambda, d e f plus lambda, and f g h plus lambda. Determinant of this can be written as a b c d e f f g h plus a b lambda d e lambda f g lambda. So when similar constant is added to all the elements of a row or a column, the determinants can be split into the sum of two determinants, right? So this property we will be applying in this question and we will try to solve the given question. Let us see. Let us see. The question given to us is x square 1 plus x cube 2x 4x square 1 plus 8x cube. From here you get 3x 9x square 1 plus 27x cube. So in this, from here in this row you can take x as common. From this row you can take x square common. So what it becomes, x cube comes out. Since x cube, x and x square is common, then x cube will come out. This will become 1, 2, 3, 1, 4, 9, and 1 plus x cube, then 1 plus 8x cube, then 1 plus 27x cube, right? So this x cube, I am keeping it like this. I can split this. You can see, right? The property that I told you, in that lambda was added to each term, and here in each term, 1 is being added. So we can split this determinant into two determinants, which will be, which will look like something like this. X cube into first determinant is 1, 2, 1, 2, 3. Then it will be 1, 4, 9. This will be x cube, 8x cube, then 9x cube. Sorry, 27x cube. Plus 1, 2, 3, 1, 4, 9, 1, 1, 1. So this will be the determinant previously has been split like this, right? The constants has been separated. Now this will become x cube. Here again you can take x cube common out, right? So the inside determinant will become 1, 2, 3, 1, 4, 9, 1, 8, 27. Plus the value of this determinant is what? The value of this determinant will be 4 plus 3 plus 18 minus 12. 4 plus 3 plus 18 minus 12 minus 9 minus 2. So this is 21, 25. This is 23. So this value is 2. This will become 2. Okay. So you get x cube into x cube. The determinant inside will become 27 4s are 108 plus 24 plus 18 minus this will become 12. This will become 72. This will become 54. And here it is plus 2, right? So you can write this as x cube into, this is 108, 24, 132 plus 18, 150. This is 126 plus 12, so 138. So this comes out to be 12x cube, and here it is 2. So you get 24x power 6 plus 2x cube. So this value has been given to us as 10. So you will get, now this value has been given to us as, here there has been some error. 108, 24, 18, 12, 72, 54. 84, 138. Oh, this is 12x power 6. This is 12x power 6 plus 2x cube equals to 10. So here you can see that this equation is reduced to 6x power 6 plus x cube minus 5 equals to 0. right? Now let us say x cube is our t. So this will become a quadratic 660 square plus t minus 5 equals to 0. So t value will be equals to t value. You can have two t values. One value will come out to be 5 by 6 and one value will come out to be minus 1. So x cube equals to 5 by 6 or x cube equals to minus 1. These are our solutions. So the number of real solution are only two real solutions. So in this question, the answer, the total number of distinct x for which, so the total number of distinct x's are 2. So this was an integer type as well. So since past few questions we have been solving integer type questions only. Okay, let's move ahead with our next question. Now here guys, the question is defined to us. Here you can see that the trace of a square matrix is defined to be the sum of its diagonal entries. If A is a 2 into 2 matrix such that trace of A is 3 and the trace of A cube is minus 18, then the value of the determinant of A. So I don't know what A matrix is, but I know that the trace of A matrix is 3. That means the sum of its diagonal entries, like the sum here and the sum here, should be 3. So what I will do now, I don't know the exact element. So what I'll do, I'll assume this to be x, this will be y, this will be z, because since we don't know the information about these two diagonal, like the other diagonal, so we won't do anything to that. We will assume different variables. But in the last element, we know that the first element this and this is supposed to be like the sum of this element x and this is supposed to be 3. So can I write this as 3 minus x? Yeah, so I can write this as 3 minus x because this is the trace and trace value is given to us as 3. Now trace of a cube is given to us as minus 18. So first of all, I'll try to find a square. A square will be x, y, z 3 minus x into x, y, z 3 minus x. So this will come out to be first row into first column x square plus yz and first row into second column xy plus 3x minus xy. Sorry, this will be 3y, right? So xy gets cancelled, so 3y will remain. Then here it will be xz. So now it will be second row into first column xz, and here it will be plus 3z minus xz. Xz will get cancelled, 3z will remain. And then second row into second column, this will be yz plus 3 minus x whole square. So the A square matrix will look like this: x square plus yz. It will be 3y here. It will be 3z here, and here it will be yz plus 3 minus x whole square. Now I want to find a cube, right? So for a cube will be equal to this a square, x square plus yz, 3y, 3z, yz plus 3 minus x whole square into the A matrix. So A matrix is what? A matrix is x, y, z, 3 minus x. So first row into first column, again the same procedure. This will become first row is first row into first column. So x cube plus xyz, x cube plus xyz. plus 3yz. Then see, for a cube, we need to find only the diagonal elements. So if you don't know these two elements, is completely all right. Let's keep that as empty itself. So we found the first element. So first element of this a cube matrix will be from first row into first column. Then this will be first row into second column. This will be second row into first column. And the last element will be second row into second column. So this will become 3yz plus 3 minus x times yz plus 3 minus x square. 3 minus x square. So the sum of these two elements is given to us as minus 18, right? So I'll be writing that the sum will be x cube plus xyz plus 3yz plus 3yz plus 3 minus x into yz plus 3 minus x whole cube. This is given to us as minus 18. So now, see, now what we will get here is, I am going to expand this part itself first. So this will become 3yz minus xyz plus 3 minus x whole cube is 27 minus x cube minus 3 into 3 into x into 3 minus x equals to minus 18. So let's write this as it is. Xyz plus 3yz plus 3yz will become, here I'll write 3yz plus 3yz as it is. Now you can see that x cube will get cancelled by x cube, xyz will get cancelled by xyz. What is remaining here is, this is 9yz, 9yz, and here it is 9x into 3. So minus 27x, and here it is 9x into minus x plus 9x square, which is equals to this 27 will go there and it will become how much? Minus 45. So we can take 9 common here. So this will become yz minus 3x plus x square equals to minus 5. Now if you see the matrix A, we have to find determinant of A, right? So the matrix A, what did we assume? We had assumed this, right? We had assumed this. So here the determinant of A comes out to be x into 3 minus x minus yz, right? So this will be minus x square plus 3x minus yz. So this is the value of determinant of A. What after the given information we have calculated this value. So does this look similar to you? So these two are similar, right? So just the minus sign, like I have to take minus sign common. If I take minus sign common here, this equation will look like 3x minus x square minus yz equals to minus 5, and this is determinant of A, right? Just now we found out. So minus of determinant of A is minus 5. That is why determinant of A value is 5. So this question had no information, but we had to calculate and just believe in, like we had to believe in ourselves that we will reach to the answer. So after calculating the value of the determinant of A, the value of the determinant of A has come out to be 5. So the answer to this question is how much? 5. Please remember the process that we did. We assumed the elements of trace by the given information. That is, their sum was 3. So we assumed x and 3 minus x. And then we proceeded with whatever the information was given in the hope that algebra will solve itself. Right? That is what we did here. Okay, guys. So I hope this question was understood by you guys. Let us move ahead and try to solve one more question. Now, here in this question, for a real number alpha, if the system of linear equations has infinitely many solutions, then 1 plus alpha square value, you have to find out the value of 1 plus alpha square. So we all know that, so in this question, the main property that you are going to use is consider a matrix M which is multiplied by this x, y, z, and the answer is like whatever A, B, C. If this equation, I'll write it clearly again for you guys. I am saying if there is a matrix M and it is multiplied by, like, this is the system of equation A, B, C. Okay. So if this system has infinitely many solution, then do you guys remember that the determinant of matrix M should be what value? It should be 0. It should be 0. So determinant of M is supposed to be 0 if this is the condition given. Okay. So we will use that property and solve this question. So the given determinant to us is 1 alpha square, 1 alpha square alpha. So the determinant of this matrix is 1. So what is the determinant that comes out is 1. 1 alpha square alpha power plus alpha power 4 plus alpha power 4 minus alpha power 4 minus alpha square minus alpha square equals to 0. So alpha power 4 will get cancelled once. So it remains alpha power 4 minus 2 alpha square plus 1 equals to 0. So this is alpha square minus 1 whole square equals to 0. So from here you can say that alpha square equals to 1, right? So alpha will be equals to plus minus 1. So we got the values of alpha for which this scenario is possible, right? But what we are saying is, but for when like consider when alpha equals to 1. When alpha is equals to 1, I'll write it here. This will become 1 1 1 1 1 1 1 1 1, and this will become x y z, and here it will be 1 minus 1 1. So this will come out to be x plus y plus z equals to 1, x plus y plus z equals to minus 1, and x plus y plus z equals to 1 again. So here you can see that Like two equations, these two equations have infinitely many solutions, correct? But when this third equation is considered, here we have this, since it is a equation in three variable, we have, I can say that we have two parallel planes in the system, right? Since the constants are differing, that means these are parallel planes and not coincident planes, right? So to have infinitely many solutions, what should be the scenario? To have infinitely many solutions, the planes should be coincident and not parallel. So since we have parallel planes for alpha equals to 1, for alpha equals to 1, that means what I will do here is I will reject this value of alpha, because you are not getting infinitely many solutions, right? So always when you get like answer, you have to check, right, whether the given like condition in the question is satisfied or not. So this is how we proceed ahead. So we have rejected the value alpha equals to 1. Now we will similarly check for alpha equals to minus 1 as well. When alpha equals to minus 1, the system of equation becomes 1 minus 1 1 minus 1 1 1 1 minus 1 1, and xyz here is given to us as 1 minus 1 1. So the system of the planes becomes x minus y plus z equals to 1 minus x plus y plus z equals to minus 1, and x minus y plus z equals to 1. Here it is minus 1. So yeah, so you can see that only second constant is differing, but there is minus sign with these two. So this will become, if you take minus common, this will again become x minus y plus z is equals to 1. So now you can say that all planes are coincident for alpha value equals to minus 1. Therefore, alpha can only take one value, which is minus 1. Hence, the answer 1 plus alpha square. What will be the answer for 1 plus alpha square? This will be alpha is, since we have gotten the value of alpha as minus 1, this will become 1 minus 1 plus minus 1 square. This will come out to be 1. So the answer to our question is 1, right? Alpha value is minus 1 and this answer is 1. So please do not confuse and go and mark the answer like this. If this can be asked in normal question also, and this can be asked in integer type also. So this time this was asked in integer type. So the answer cannot be like, there is no options to mark minus 1 in the question paper. So that is why positive integer is most of the time the answer, like not most of the time. This is how the questions are framed. So answer will be equal to 1. Okay. So Yeah. Let us solve one more question. Let us solve one more question and try to wrap up our session. This In this question, there is a matrix given to us. There is a matrix given to us with the condition 3 into 3 matrix. The condition for 3 into 3 matrix is given like in different scenarios to be like this. So the sum of the diagonal entries of M. We have been asked the sum of the diagonal entries of M. So I am saying let us assume the matrix M to be A, B, C, D, E, F, G, H, I. Okay. So we are supposed to find what? We are supposed to find diagonal sum of the diagonal entries, which is A plus E plus I. Okay, guys. So this is supposed to be found by us. Now, to find this thing, there is information given. So matrix M multiplied by this matrix is equal to -1. So can I write it as 0 plus B plus 0 equals to -1? I am solving this first two question, first relation. Here you will get 0 plus E plus 0 equals to 2 and 0 plus H plus 0 equals to 3. So from this you can get the values of B equals to -1, E equals to 2 and H equals to 3. So we have found out three values. Now I will try to solve these two matrix, right? The second condition. So this is from first condition. From the second condition, I can get A minus B plus 0 equals to 1. Then D minus E plus 0 equals to 1. Then G minus H plus 0 equals to -1. So from the second condition, B value is known to you, right? B is -1. B value is -1. So here 1 plus B. So 1 plus -1 will be 0. So A value will become 0. So D, E value is 2. So D value will become 3. D will become 1 plus E and E is 2. Hence, I'll use this here and I'll use this here and I have used this here. So D value will become 3. Now G value will be -1 plus H. H is 3. So -1 plus 3 will be what? -1 plus 3 will be 2. So this has come to us by solving the second condition. This has come to us by solving the second condition. Now if you try to solve the third condition, you will get A plus B plus C equals to 0, D plus E plus F equals to 0, and G plus H plus I equals to 12. So we already know we are supposed to find A, E, I, sum of A, E, I. We know the value of A. We know the value of A. I'll mark it with different ink. We know the value of A. We know the value of E. We need to find the value of I. So to find the value of I, you need not solve these two questions. Sorry, these two equations. This equation will be more than enough. So I will be equals to 12 minus G minus H. So 12 minus G value is 2 and H value is 3. So this will come out to be 7. So A plus E plus I is equals to how much? A plus E plus I will be equals to A value is 0, E value is 2 and I value we found out to be 7. So this will give us the sum of the diagonal elements to be 9. So the answer to our question, the answer to this question is 9. So the sum of the diagonal entries of M is equals to 9, right? So this was very easy question, right guys? Very easy question. So sometimes these type of questions also come, and that is why You need not panic if it is a JEE advanced exam. Whatever happens, if you are calm over there, if you be patient and if you like don't panic, then you will definitely be able to solve any type of questions if you have decent amount of concepts built while preparing for mains exam. I hope you like this session, guys. Thank you so much. Have a good day. Tomorrow we will be meeting to discuss previous year questions on some other chapter which is also important and carries a lot of weightage in the exam. Have a good day.